So a lot of you have been asking me to do something around YOLO and YOLO object detection. So what I ended up doing is testing this out for drowsiness detection. This is what it looks like. What's happening, guys? My name is Nicholas Renaud, and in this video we're going to be using YOLO for object detection, and specifically we're going to be using it to try to detect when we're drowsy and when we're wide awake. Now, the particular model that we're using, specifically the YOLO model that we're using, is a little controversial. It's not the official YOLO version, but that being said, it is a ridiculously useful production implementation of the YOLO algorithm. So we're going to be going through YOLO today. Let's take a deeper look as to what we'll be going through. Alrighty, so in this video, we're going to be going through 4 key things. So specifically, we're going to be using the Ultralytics implementation of YOLO. Now, I may have got into a little bit of a fight on Reddit about whether or not this is the official YOLO implementation, but that being said, it is a really good production implementation, which is built using PyTorch. So we're going to be leveraging that today. What we're then going to do is leverage the base model to perform some detections, and I believe it's trained on the Coco dataset, so you're going to have roughly 80 different classes that you're able to detect right off the bat. And then what we're going to do is fine-tune our drowsiness model. So we're going to be able to detect whether or not we're drowsy or whether or not we're wide awake and pinging. So then what we're going to do is actually test this out in real time. So we'll be able to leverage our webcam to be able to perform real-time detections to determine whether or not we're drowsy. So you could take this away and potentially implement it in a car or a vehicle to make sure that you're not dozing off, potentially trigger an alarm or something off the back of this to make sure that you're a lot safer on the road. Let's take a look as to how this is all going to fit together. So first up, what we're going to be doing is installing the Ultralytics YOLO package. So this is a implementation of YOLO. So it's not the official YOLO v4 implementation. It's called YOLO v5, but again, let's not comment about that Reddit fire that I had. So what we're going to be doing is leveraging the Ultralytics YOLO implementation to be able to fine-tune a drowsiness model. We're going to use a label image to label our images. So if you've seen my large TensorFlow object detection tutorial, it's going to be pretty similar as to how we actually go about labeling our images. And then last but not least, we're going to be able to make some detections as to whether or not we're awake or drowsy. Ready to do it? Let's get to it. Alrighty, guys, so in this video, we're going to be going through drowsiness detection. Now, in order to do that, we're going to be going through 6 key steps. So first up, what we're going to do is install and import our dependencies, and we're really going to be using PyTorch quite a fair bit for this. Then what we're going to do is load up that model that we're going to be leveraging. So again, we're going to be using a YOLO, or what's known as YOLO v5. Again, it's like an unofficial, I guess, extension of YOLO v4. So we'll be taking a look at that. Then we're going to be making some detections using the baseline model, which has been trained on Coco. So if you haven't heard of Coco before, basically it's like this open source data set, which I think has around about 80 different classes. So the nice thing about this implementation is that you can try it out. You'll see some detections without even fine tuning. But then what we're going to do is we're going to collect some images using our standard image collection code, train a model to detect whether or not we're drowsy or not, and then we'll actually go and make detections in real time using our webcam. So again, we're going to bring it all together and basically have a fine-tuned drowsiness model by the end of this. Now, the first thing that we need to go on ahead and install is PyTorch. So if we go on ahead to pytorch.org, what we can go on ahead and do is just go to the install section right over here. Hit install, and then what we're going to do is choose the version that we're going to install. Now, we can choose stable 1.9. I'm going to choose the long-term stable version, which is 1.8.1, because that's worked for me. Pretty straightforward, but again, feel free to use whichever one you want. And then what we're going to do is choose what OS we want to use. So I'm going to use Windows, and then we're going to choose what package. So pip, let me zoom in on this so you can see it a little bit better. So package, we're going to use pip, and then we're going to use Python. And then I've got CUDA 11.1 installed on my machine, so I'm going to choose that. If you don't have a GPU, that's fine. It's just going to take you a little bit longer to actually go on ahead and train this, but it's all good. So what we're going to do is choose the different options that we want, and then we can copy this down and jump back into our notebook, and let's kick off with step 1. So what we're going to do is first up install PyTorch. I'm just going to include an exclamation mark, paste that in, and then I'm going to get rid of the 3 here and run that. And I believe I've got PyTorch pre-installed in this YOLO kernel already, so we should be good to go. Yep. And as per usual, all this code is going to be available inside of a Jupyter Notebook via GitHub. So I'll include the raw stuff that we write in this tutorial as well as the refined code, so you can have a cleaned up version. But for now, let's keep going. So we've got PyTorch now installed. Now, the next thing that we need to do is actually go on ahead and grab this Ultralytics YOLO V5 model. So if I type in YOLO V5, I think there's only one out there. Okay, maybe not. It should be YOLO V5. All right, here we go. So this is the Ultralytics YOLO V5 implementation. Now, again, as I was saying in the intro, there is a little bit of controversy around the naming of this particular model, particularly because it's not like an official branch of the YOLO V4 implementation. But I found this and it actually worked really, really well, particularly for like production implementations and particularly for practical implementations. So I wasn't intending on actually making this tutorial around drowsiness detection, but I was like, hey, let's give it a crack and see how it goes. And the end results were actually really, really surprising. So again, a little bit of clickbait. You stick around to the end and you'll see the full results. But again, it's really, really good. Okay, so what we're going to do in order to get this is we're going to clone this repository. So you can see that it's got a git clone command there. So we'll clone this. And you can see here that this is basically what we're going to go on ahead and do. So we're going to clone it, we're going to cd into it, and then we're going to install the requirements for the YOLO V5 implementation. So if we copy this, I'll show you how to do it in a notebook, and jump back into our notebook, add a new cell. So I'm going to type in exclamation mark and then git clone that. So it might take a little while. I've already got it cloned, so I don't need to go on ahead and clone this, but assuming that I didn't have it cloned, it's going to go on ahead and clone down. So let me show you what it looks like. So if you get this error here, that basically is just a warning saying you've already got it cloned or you've already got it there. So in my folder, you can see I've already got a folder called YOLO V5, and this is basically what you're going to get cloned down. So if we go and take a look at that, everything that you see over here has just been cloned over to here. So basically, we're now going to be able to leverage a YOLO V5 implementation. But before we do that, we need to do one more thing. We need to install the dependencies inside of this requirements file. So what it's going to go on ahead and do is just make sure that we've got all of these different dependencies or libraries, modules, whatever you want to call them. It's just going to make sure that we've got all of these installed. So let's go on ahead and run this. Now, I believe we've already got Torch and Torch Vision installed. It's going to go on ahead and do the rest for us. So let's go on ahead and do that. So we can go on ahead and grab this command here. So pip install our requirements.txt, and we're just going to include another command. So first up, we need to cd into that folder. So cd YOLO V5. And then what we want to do is pip install -r requirements.txt. So effectively what we're doing is from our command prompt, we're cding into that YOLO V5 folder and then installing those requirements that you saw in that requirements.txt file. Let's run that. Looks like we've already got them all installed. No errors there. And that's pretty much the core install now good and done. So let's quickly recap. So what we've done is we've installed PyTorch through this line here. And remember, we just passed through our settings that we wanted, went and copied the command into here and ran it. We then went and cloned that repo, and then we went and installed the stuff inside of requirements.txt. From here on out, it's all reasonably straightforward in terms of what we need to do. So there's not too much cloning and installing. It's really, apart from label image, we've got to do that as well. But that's all good. We'll walk through it. So now that we've installed a bunch of stuff, what we now need to do is import it into our notebook. So let's go on ahead and do that. Okay, that is our initial set of dependencies installed or imported into our notebook. So we're going to import a bunch of stuff later on as well. But for now, those are our 4 key dependencies that we need to go on ahead and load our model, make some initial detections. So what I've gone and written there is import torch. Then I've gone and written from matplotlib import pyplot as PLT. So this first line import torch is going to import PyTorch. The second line is going to import matplotlib, so we can actually do a little bit of rendering. Then I've gone and written import numpy as NP, and this is just going to help us with a little bit of data transformation. So if you haven't worked with NumPy before, basically it's a really, really powerful array transformation library from Python. So again, super powerful. We can do a bunch of stuff with that. And then we've gone and written import CV2. So this is going to import OpenCV into our notebook and allow us to get started. Okay, now the next thing that we need to do, so that's pretty much step one now done. So we've gone and installed PyTorch, we've gone and cloned our repository from GitHub, and then we've gone and installed the dependencies from the requirements.txt file. So, and then we've also gone and imported a bunch of dependencies into our notebook. Now, the next thing that we need to do is actually go on ahead and load our model. So let's go on ahead and do that. Okay, so I've gone and written one line there. Now, let me explain what this is actually doing. So this is actually loading the pre-trained Ultralytics model from Torch Hub. So if I go to Torch Hub, and this is sort of like TensorFlow Hub, but it's the PyTorch equivalent. And if we actually go and search for, how do we go and search on here? Let's try Ultralytics. Here we go, YOLO V5. So what it's basically doing is it's downloading the pre-trained model from PyTorch Hub. So this is sort of a place where models can be hosted. And we're actually going to be using the baseline model. Now, there's a couple of different models that are actually available through this. There's a small model, a medium model, and you can see them there. Small model, medium model, large model, and an extra large. I believe it's an extra large model. And it sort of shows you the comparisons between each of these different models. So we're going to be using the small model to begin with, but again, if you wanted to use a bigger model or a more hardcore model, you definitely could. Now, what we're going to go on ahead and do is actually load that up. So what I've written is model equals torch.hub.load, and then I've passed through the package that we want to use. So Ultralytics / YOLO V5. And then I've passed through the actual model that I want to use in this particular case, because there's those different versions of YOLO V5. Remember, there is the small, medium, large, and extra large version. So we're going to be using the small one to keep things lightweight and quick. And then what we've gone and done is by downloading all of that, we're going to store it inside a variable called model. So the full line is model equals torch.hub.load. And then the first parameter is Ultralytics / YOLO V5. And then the second parameter or second argument is YOLO V5S. So if I run that now, it's going to go on ahead and load it up. And you can see it's picked up my GPU over there. Still waiting on those 3090 prices to go down, guys. All right, cool. So that's now gone and downloaded, and we've now gone and loaded it into our notebook. So you can see that we didn't get any errors there. So if we go and take a look at our model now, you can see that you're actually able to take a look at all the different layers that are available inside of this model. And you can see it's massive, right? So we've got a bunch of convolutions, plus I believe this was a sigmoid linear unit. There's a whole bunch of stuff inside of this. And there's a bunch of prediction heads coming out of this as well. But all good. We don't need to delve too much into the architecture. Again, I'll include a bunch of links about this below as well, so you can take a look at it. What we're now going to go on ahead and do is make some initial detections. So say, for example, we wanted to detect some stuff inside of an image. We can actually do that. So first up, what we're going to do is grab an image, and I'm going to grab the image that they use in the official documentation. So let's try that out. So we're going to create a new variable called image and then pass through a link. Okay, and this should be .com. So what I've gone and written there is image equals, and then I've passed through a string. And again, this is just for our initial baseline detection, which is going to be off the Cocoa dataset. So if you actually type in Cocoa classes, let me show you this. So there's a bunch of different classes that you've got available within Cocoa, right? So you've got person, let's zoom in on this person, bicycle, car, motorcycle, airplane. I actually started testing this out for my object tracking tutorial, which is coming up in, I don't know, a couple of days. And it actually picked up the cars really, really well in the traffic video. So it's actually pretty cool. So we might actually switch this out later on. But for now, you can see that there's a bunch of different classes that are available inside of this baseline model. So we're going to be leveraging those. And again, I'll include a link to this as well in the description below. But for now, let's go on ahead and make some detections. So what we can do is we can pass that image to our model. So I can type in results equals model and then image, and then we can print out our results. So results.print. Okay, so you can see that we've got some results. And let's actually take a look at the line of codes or the 2 lines of code that we wrote, and then actually take a look at how this worked. So we've written results equals model, and then to that we've passed through the image that we want to make detections on, and that image is just a string. So it's just this over here. And then I've written results.print, and this actually prints out the results from that object detection model, but it doesn't render. So I'll show you how to do that in a second. So what it's actually gone and said is it's image 101, so we've only passed through one image, and these are the dimensions of the image. So it's 720, but let's zoom in on that, 720 by 1280. It's detected 2 persons, so 2 people in the people class, and 2 ties. So these people must be wearing ties. It's also given us the speed. So in this case, it's 1,317 milliseconds. And then it's also given us the time for inference, the seconds per image shape. So again, it's giving you a bunch of information over there. Now, at the moment, we're not actually rendering anything. So we might actually want to do some rendering. So let's go on ahead and do that. And there you go. So we've now gone and drawn our different classes. So you can see there that the image is a picture of Zinedine Zidane, and you can see that it's gone and detected the class of person for him. So it's all the way through his body, and it's also detected his tie. And again, I don't know, this guy is probably some soccer dude. I'm probably going to catch some fire in the comments for that. But it's detected the class of person, and it's also detected a bit of his tie as well. So let's actually break this down a little bit. So what we actually get out of the results from this model, so if I type in results, you can see that right now this is just the base class, but if we actually type dot and then tab, there are a whole heap of different components out of this. So you can see that we're actually able to get the XY coordinates, and this gives us all of the different coordinates for our particular model. So you can see it's got X, Y, X, Y. I believe that's the case. It might actually have the confidence metrics as well. But this is giving us the coordinates for our particular model. What else are we able to get? So if we type in .show, what's that going to do? Oh, that's not actually, that's actually opening up the entire image inside of and completely separately. I haven't actually played with this one, but that sort of gives you an idea as to what's possible. You can also type in results.render. And this is actually going to return the image or the image with the detections drawn on it. So again, it's really, really quick. It's able to actually draw that image. So what we've actually gone and done in order to render it like this is I've first up made sure that we can render inline using matplotlib. So I've used some inline magic. So I've written percentage sign, matplotlib inline, and then we've gone and used the matplotlib imshow function to actually go and render. So if you actually take a look at the shape of this model, that doesn't have a shape. What do we have here? So let's put it in a NumPy array. And if we type shape, you can see that it's encapsulated in another set of arrays. Now, in order to render using matplotlib, we need to basically squeeze this and extract just these components. So we want the 720 by 1280 by 3. So if we change this numpy.array function to numpy.squeeze, you can see that we're going to get that. And then to actually render it, we can just type in plot.imshow, which is a built-in matplotlib function, and get rid of .shape. And this is going to allow us to render our image. So in order to show it the first time, I've just written plot.show as well. So that allows us to actually go on ahead and render our image. Pretty cool, right? So again, this is really, really lightweight and sort of shows you what's possible in terms of making detections. Now, let's find an image of car traffic. So car traffic, I personally think this is super cool. So you can actually extract a whole bunch of classes from cars. Let's get one where you've got some defined cars. Let's try, I don't know, this one. And if we open our image in a new tab, so we just want the copy image address. Okay, that should be good. Let's see if that works. So if we grab that link now and sub it out over here, it's a giant link. See if it works. Okay, so it's actually gone and detected those classes. And again, all I've needed to do in order to go and make detections on a completely different image is pass through the new link. So what I did is I went and found an image and just updated this image variable over here. And by running this next line, you can see results equals model.image. So we've gone and passed that image to our model again and saved the results inside of a results variable. And then by writing results.print, we're able to get all of this metadata here. So you can see it's detected 38 cars. Oh, mouse is lagging. Detected 38 cars, and it's also detected 4 different trucks. And you can see it's given us our speed. So it's actually relatively quick. Now, if we go and render this image, how cool is that? So it's actually rendering all of the different classes that's actually gone and been detected. So it's detecting all the cars, it's detected the trucks. Pretty cool, right? And with reasonable confidence intervals all the way out to there. I think this is personally, it's like one of the coolest models that I've worked with. And again, we can run this function down here. This one's just sort of a copy of that, but just sort of explaining how it works. But that shows you how you can build baseline detections using this particular model. Cool. Now, we could also do this with OpenCV as well and do it in real time. So let's go on ahead and do that. So I should probably say that that is step 3 now done. So we've gone and made some initial detections. So we've gone and captured our images, made some detections using an image. We've gone and rendered them as well. But now what we're going to do is go into step 4, where we're going to do it in real time. Now for this, we're going to use a pretty common OpenCV loop where we're actually able to access the image from our webcam, and we'll do it with our baseline model to begin with. So let's do this. Okay, so what I've gone and written there is if you've ever watched any of my standard computer vision tutorials, this is going to look super familiar to you. It's just accessing our webcam and it's going to allow us to make detections in real time. So what I've written is cap equals cv2.video capture, and this is just accessing our webcam because my webcam is video capture device 0. But again, if you don't get a real-time feed, just play around with that. It might perform, or you might need to change it from 0 to 1 to 2. So on my Mac, it's video capture device 2. On my Windows machine, it's video capture device 1. And then what we're basically saying is we're going to loop through the feed from our webcam. So what we're first checking is whether or not our capture device is still open. So while cap is opened, and then we're reading our capture. So cap.read, and we're extracting or unpacking the variables from that capture device. So ret, comma, frame equals cap.read. And what you're actually going to get back is a return value plus the frame or the image from your webcam. And then what I've written is cv2.imshow, pass through the name of the frame. So this is when you actually go and render, you'll get a little pop-up. And the top bar is going to be named whatever you pass here. So if I wanted it to be called YOLO V5 or Ultralytics or drowsiness detection, all you need to do is change this variable here and it will change what's rendered. Then the next argument that we've passed through is frame. Then everything below that is all to do with exiting out of this gracefully. So what we're effectively checking is between each couple of frames, whether or not we're pressing the Q key on our keyboard. So in order to do that, we're checking if cv2.waitKey 10 and 0xff equals odd Q. So that's what we've written in order to do that check. And if that check passes, then we're going to break out of this loop. So we're going to break out of this while loop, and then we're going to do some cleanup. So we're going to release our capture device, so release our webcam, and we're also going to destroy all the windows. So you'll see that we'll get a little pop-up. We're going to destroy that. So let's go on ahead and run this. And this isn't actually making detections as of yet. This is just accessing the real-time feed. So let's run this. Make sure it works. And we should get a pop-up. All right, so we've got a pop-up. You can see my head. So no issues there. So that's looking all well and good for now. But what we actually want to do is make some detections using the YOLO model, right? So let's quit out of this and let's update this code. So there's just a couple of lines that we need to update in order to make our detections. Okay, so there's a first change that we've gone and made. So first up, what we're actually going to go on ahead and do is make some detections. So in order to do that, we're going to use our YOLO model and we're going to pass through the frame that we get from our webcam. So remember when we run cap.read, we're going to get a return value plus our frame back. Now, in order to make detections, what we need to do is pass that frame to our model, and we're going to get our results. So no different to what we got up here. Now, the last thing that we need to do is actually make an update to our cv2.imShow function to actually go on ahead and show those results. So let's do that. So what we're going to do is run results.render, and we're going to wrap that inside of our NumPy function, which is going to squeeze it. So np.squeeze. Let's make sure we've got enough brackets. Yep. Okay, cool. So that is the only change. So before here, what we had is, let me just cut that out. So we had frame. Instead of that, what we're going to do is we're going to use the results.render method, because remember, the results.render method only returns the image array. So if I type in results.render, so what we're getting back out of this is the NumPy array the array representation of the image. In order to actually render it, we actually need to pass it through to a rendering function. In this particular case, we're going to be using cv2.imShow to do that. And remember, we need to squeeze out the result. So we need to extract it out of that big array. And if we go and run this now, we should get some results. So let's try it. Okay, so if you get a little pop-up and it closes, perfectly fine. Just go on ahead and run it again. Cool. So you can see that that's working pretty well. It's detecting this as a cell phone. But if I actually throw up a cell phone, you can see it's detecting that as cell phone. I don't know, headphones, does it work? What's it saying? It's calling that a remote. It doesn't want to do that. I'm trying to find something else. What about iPad? Saying that the iPad is a chair. That's cool. What about if we took the green screen down? So you can see it's detecting a bunch of stuff in the background. So it's detecting the couch, it's detecting that I've got all the chairs on my dining table. It's even detecting the potted plant over here, which is pretty cool as well. So you can see that really, really quickly, you're able to get up and running and testing this out. Now, at the moment, we're only doing it using real time, and we're not doing it using a fine-tuned model. So we might want to improve this a little and actually fine-tune and build something actually specific. But before we do that, I want to show you one more thing. So right now we're doing it using our webcam, but what if you wanted to do this using, say, a video? Let me show you how to do that. So in order to quit out of this frame, all you need to do is hit Q on your keyboard, and that's going to close it down. Now, say, for example, we wanted to do it using a video. Now, I've got a video of some traffic data that I was looking at recently. Let me show you what that looks like. So it's called traffic. And that is ridiculously tiny. There you go. So you can see it's just an image of a bunch of cars. Now, say, for example, we wanted to perform our object detection on that video. How would we go about doing that? So the file name is called traffic.mp4. So all we need to do in order to make detections off a video instead of off our webcam is to change this value here. So if I type in traffic.mp4, you're now going to get detections from that video. And I've got the pop-up, it's closed. Let's try running that again. So you can see it's now opening up with our video. And you can see all those detections in real time. And look at how quick it is. It's ridiculous. Like, honestly, for a open source implementation, this is so, so good. Even though it might not be the official YOLO v4 model, look how good this is. It's detecting all of the cars in the frame, and it's ridiculously quick as well. Pretty cool, right? So, I mean, you can see that there are a ton of possibilities with this. So right now, it's just trained on the base Coco model. But what happens if we wanted to go and train this on something else, for example? Say, for example, we wanted to go and fine-tune our model. You can definitely do that as well. But for now, just look at the speed of this thing. I mean, it's pretty cool, right? Gonna make this a bit bigger. No, doesn't want to go bigger. Not too shabby, right? All right, enough taking a look at that. Let's close that down. So, all right, so what we can do is sub this back out and leave this as 0. So that is step 4 now done. So we've now gone and performed our real-time detection. So if we take a look at what we've done so far, we've sort of sped through this. So we've gone and installed and imported our dependencies. We went and loaded our model from Torch Hub. We then went and made some detections. And remember, all we needed to, made detections with images. Probably update this with images. So what we then went and did is we grabbed a link, passed that to our model, and was able to make detections. And then we made real-time detections both with a video and our webcam. Now what we want to go on ahead and do is actually train a custom model. So rather than it just being trained on the Coco classes, say, for example, we wanted to go and train this using some custom labels. Well, what we're going to go on ahead and do is now train our drowsiness detector. So first things first, what we need to do is collect some images and then label them. So I'm going to copy this loop over here, and we're going to use pretty much this same loop to go on ahead and collect our drowsy and non-drowsy images. So in order to get started with that, we need to import a couple of additional dependencies. So let's go on ahead and do this. Okay, so I've gone and written 3 different lines of code there. So first up, what we've gone and written is import UUID. So import UUID, and then we've gone and imported, and we're going to use UUID to create a unique identifier. Unique identifier. And this is going to be used to actually name the images. So we're actually going to collect images in real time of myself to go and perform this drowsiness detection. So we're going to do that. And then we're going to use import OS to actually leverage or work with our file paths. Just makes it a lot cleaner to do that. And then we're going to use time to take a little bit of break between each one of the images that we actually go on about collecting. Now, what we can actually do is update this code here to not just capture the real-time feed, but also save the images for our different classes. So let's go on ahead and make these updates. Actually, you know what? It's probably going to be cleaner if we write this from scratch. I'd rather do it from scratch. Let's do it from scratch. Okay, so let's go on ahead and do this. Let's add in a couple of cells below so we can do that. Okay, let's do it. Okay, so before we go and write up our image collection loop, we need to define 3 key variables. Now, if you've watched the full TensorFlow object detection course that I made, this is going to be really, really similar. So first up, what we're going to do is create an images path. And this is where we're going to save our images, or effectively our image data. And in order to do that, I've written images underscore path equals os.path.join. And then I've specified what we want our top folder to be and what we want our subsequent folder to be. So basically, all of our images are going to be saved inside of a folder called data/images. So it's effectively a subfolder of our data folder. Wow, that was different. It's going to look like this. So data/images, like that. Coolio. All right. And then we're going to collect 2 different types of images. So we're going to have 2 classes that we're going to work with. We're going to have awake, so basically me looking alive and on it, and not what I'm looking or feeling like right now, and then me looking drowsy, so like a little bit down and disheveled and maybe closing my eyes. And then the third parameter, or the third variable that I've gone into, and actually let's take a look at labels. So in order to do that, I've written labels equals, and then inside of square brackets, I've just passed through 2 strings. So first one is going to be awake, second one is going to be drowsy. Then the next variable that I've specified is the number of images that I want to collect. So I've written number underscore images, or IMGS, equals 20. Now, what we can actually go on ahead and do is, actually, we haven't actually run these cells. So what we can go on ahead and do is actually now leverage these pieces of information. So what we're going to do is we're going to loop through our labels. And so we're going to collect images for awake first, and then we're going to collect images for drowsy. And for each one of these labels, we're going to collect 20 images for each. Then eventually what we're going to go on ahead and do is label them using a library or a package called label image. So I'll show you how to get that set up as well. But for now, let's go on ahead and start writing this loop. Okay, so those are our first 4 lines of code written. So the first line that I've written is cap equals cv2.video capture, and then I've passed through video capture device 0. So again, no different to what we were doing up here. Then the next line that I've written is the kickoff of a loop. So for label in labels, so we're just going to be looping through our labels over here. So if we do that, so for label in labels. So if we went and printed out our label, right? So effectively, all we're doing there is we're looping through each of our labels. Then what we're going to do is I'm actually going to print this out. So we'll actually see when we're collecting or transitioning between labels. So I've written print, and then inside of a string, so I've written collecting images for, and then I've put through some curly braces. So this is going to allow us to perform some string formatting and inject our variable into it. Then I've written dot format, and I've passed through our labels. So this is effectively just going to be printing out the different labels inside of a nice string. So if I go and run that, this should be label, good pickup. So it's going to be printing out, first up, collecting images for awake, and then collecting images for drowsy. Then what we're going to do is we're going to sleep for 5 seconds when we're transitioning between each of our different labels. Then what we want to do is we want to loop 20 times now. So we're going to loop through each one of the images that we want to collect. So let's go on ahead and do that. Let's add some commentary as well. So this is the first loop, loop through labels. This is the second loop, loop through images or image range. Let's do it. Okay, so that's the next 3 lines of code. So I want to sort of take this step by step so we don't just fly through it and I'm not explaining what I'm writing. So what I've then gone and done is we're going to then loop through all of our different image numbers. So remember, we've got a range that we want to loop for. We want to collect 20 images for each one of these classes. So I've written, so for image underscore num in range number underscore images, which is going to be looping through this value. And then we've effectively gone and applied a little bit of string formatting, similar to what we did up here. But this time we're going to be printing out collecting images for, and then we're going to print the label and then the image number. So what image we're actually up to. And then no different to how we accessed our webcam before. I've written ret, comma, frame equals cap.read. So we're going to read the feed from our webcam. So if we take a look, this is going to be akin to doing this. So let's copy this, put that inside of there. So you can see it's going to first up print collecting images for awake, and then print collecting images for awake, image number 0, all the way up to 20. So it starts at 0 but ends at 19, so 20 images. Then what we're actually going to do now is we're going to access our webcam. We're going to take a picture, so sort of like taking a photo, and we're going to save that to our disk. And remember, we're going to save it inside of our data folder, and specifically the images folder inside of that folder. So let's go on ahead and do that. And we should probably also actually create that folder as well. So let's go on ahead and do that first up. So I'm going to go into the main folder that I'm working in, so YOLO v5, and I'm going to create a folder called data. And then inside of that, I'm going to create a folder called images. Cool. Let me zoom in on that. Right, so if we take a look, so this is my top level folder. So if I go into data and images, all of our images are going to be written here. So remember, you just need to create a top level folder called data and then the secondary one called images. Okay, now let's go on ahead and finish this off. So we're going to first create a unique name for our image, then save our image, and then we'll actually wrap this up. Okay, so we've gone and written, what is that? 4 different lines of code there. So I've gone and applied these new lines. So I've written image name equals os.path.join, and then to that we've passed through the images path. So remember, when you actually name this image, or we're, in the next line, we're actually going to write it out, we need to pass through the full file path to this particular image. So what we're effectively doing there is we're passing through the initial file path, so where we're going to store these images, and then we're just creating the name of the image here. So let's actually take a look at what this would look like. So if I copy this, paste it down here and print out our image name. So what it's going to do is it's going to create, so again, this is what we wrote in the first couple of lines. This line is going to create a full file path to our image. So data, comma, images, and then the first image is going to be called awake. And then we've got this weird number here. Actually, we need to pass through .jpeg as well. So we need to plus .jpg. That should be better. There we go, should be that. Let's actually replace this line before we forget. So what we've actually gone and written is, or what is actually happening here, is we're grabbing first up our images path, so data, comma, or forward slash, backward slash images, and then we're specifying the name of the class, our unique identifier so they don't overlap or override each other, and then we're passing through .jpg, so this is going to be the file extension. And in order to do that, I've written image name equals os.path.join, and then we first up pass through our images path, and then this is where the magic happens. So first up, we're passing through the name of the label, and then we're passing or appending a dot to that. So I've just used pluses in this case. You could use string formatting, probably be a little bit cleaner. So plus dot plus string or str, and then this UUID function here is going to be what creates this component. So that over there. Then I've written plus and then the .jpg. So this is going to append the .jpg bit down there. So let's actually take a look at that. So effectively we've got, so let's say our label is going to be drowsy in this particular, let's grab one label. So if I type in labels.0, it's going to be awake. So what we're effectively doing is we're going plus dot. So that gives us, let's close this so we don't need to see that. So plus dot and then plus UUID, so we need to wrap that in a string. So UUID dot UUID1. Right, so that's giving us that bit, and then we're adding the .jpg. And that gives us our full file path. Now, if we go and append data, what is it, images path? And we need a forward slash, but we've gone and used the os.path. So that's effectively giving us that. Now that's obviously not all that clean. So if we used os.path.join, it's going to be way cleaner. That is how we're creating this over here. Now you saw that when we printed it out, we didn't get that double backslash. That's just a function of the os.path library. So you can see it gets rid of those double backslashes, which are effectively the escapes. Okay, so that is that line explained. The next line, detailed explanation, but I wanted to go through that. So the next thing that I've gone and written is cv2.imWrite, and then to that we've passed through the full file path to our image that we're going to be writing out. So in this case, it's image name, and then we've gone and passed through our frame. So remember, our frame is what we're capturing from our webcam. So this is our webcam feed. This is naming our image path. So cv2.imWrite is going to be what actually writes out our image. So writes out image to file. And then this down here, or this cv2.imShow function is no different to what we used up here to show our initial results. So this is going to render to the screen. And then I've included a time.sleep function to basically give us a little bit of time to move around between each image being collected. So this is going to give us a 2-second delay between captures. So in order to do that, I've written time.sleep and then I've passed through the value 2. So no different to what we did up here where we passed through time.sleep 5. And again, if you wanted a shorter break between the image captures, you don't need to pass through 2 or 5. You can drop it to whatever you want, but it's in seconds, so you can adjust it as needed. Then the last thing that we're going to do is we're actually going to copy this breaking gracefully code and append this down here, or put this down here. And that is pretty much our loop done. This should be tabbed in. Like that. Cool. So that is our image capture code now done. So let's go on ahead and test this out. So we might do a test run, and if it works, then we should be good. If it doesn't, we'll try it again. So let's run this. And ideally, as we're collecting images, we should see this folder start filling up. So we're going to collect images for awake first and then for drowsy. So I'm going to move this over to the side so we can check, make sure we're getting images. So we don't have a pop-up yet. It should come soon. Okay, so you can see it's collecting images. So awake. So I'm actually going to quit out of this. We still going? Okay. So rather than collecting images with a green screen background, I want to drop the green screen just so we've got a little bit of noise in the background as well for our image collection. So let's go on ahead and drop down the green screen. And then, so first up, we're going to collect images for me being awake. So eyes wide open, looking up and around, and then drowsy. So sort of like eyes closed, head down, that type of thing. So let's go on ahead and do this. So I'm going to move the mic away, drop the green screen so that's not there, and then we're going to run this cell, and eventually you're going to see all these images being captured. So let's go on ahead and do this. We don't have our pop-up yet. Should come up any second now. There we go. So wide awake. Just moving my head around, eyes wide open. Won't exaggerate it too much. And again, you could do this at a whole bunch of different angles. Are we up to drowsy yet? Nope, still awake. 16. So you can see that being printed down the bottom there. All right, cool. Now, drowsy, so eyes closed. Doing number 11, cool. All right, cool. That's 19 images now collected. So let's take a look at what we've got there. So we've got our images inside of our folder. That one's a little bit overexposed, but you can see I'm looking awake there. And then I'm drowsy. So you can see we've got our drowsy images as well. And drowsy is pretty clear because my eyes are closed. I'm starting to fall asleep. That's going to be an indication as to whether or not we're drowsy, right? Okay, now what do we need to do next? So let's close this. So what we now need to do is we actually need to go on ahead and label these images. Now, in order to do that, we're going to use the label image package. So if I show you that, again, I'll have a link to this in the description below. So, but in order to access it, you can go to github.com. I can never pronounce this, but it's TZUTALIN and then /label image. So this repository over here. All right. Reasonably easy to get up and working with, and it works pretty well. So what we're going to go on ahead and do is use this. So what we need is this link here. So I'm going to copy that. I'm just trying to look over my mic to my keyboard. So let's go on ahead, copy that, and we are going to clone this. So git clone. Should probably add another section for this. That's fine. So git clone, paste that in, and this is going to clone into our current working repository. So let's go and do that. And effectively what you should start seeing is that we will now have a folder called label image. So you can see that that's already been created there. And we're going to wait for that to clone down, and then we'll go on ahead and install it in a sec. Okay, that is label image now cloned. Now, if we go and take a look, you can see that we've got that clone there. Let's zoom in. And you can see we've got a bunch of, where are we going? You can see we've got a bunch of stuff available in there, right? But right now, as of yet, it's not fully installed. So we actually need to go on ahead and install this. So let me walk you through that. There's really just two commands, but basically the first one involves this .qrc file. So if you don't have that in there, just clone it down again. And then the first command is we need to install a couple of dependencies. Then the second one is just going to be with pre-processing this resources.qrc file. So let's go on ahead and write the two commands to do that. Okay, so before I go on ahead and run that, let's actually take a look at what we've written. So the first line is actually installing some dependencies, and there's two key dependencies here, PyQt5, which I believe is a GUI library, and then LXML, I believe is a dependency of PyQt5. So the first command is !pip install PyQt5 and then LXML, and then -- upgrade. And the second command is !cd, and so this second command is actually working with that resources.qrc file that I mentioned. So what we're doing is we're effectively CDing into that label image file, because remember we're in the top file repository at the moment. So we'll go into that. And then what we're going to do, so end, we're going to run pyrcc5-o, and then we're going to pass through libs/resources.py and then resources.qrc. This is just part of the standard installation code for label image. So if you actually go, I'll show you where it is. So I'm on a Windows machine, so you can see these commands here. All right, so I'm using pyrcc5, that's fine. You can use whichever one you want. But if you were using a Mac, for example, you'd be using these commands over here, right? So it's slightly different. If you're using Linux, it's going to be this over here. Cool. So what we're now, let's actually go on ahead and run these. So we haven't run them yet. Cool, so that's now gone and done. Now what we can actually do is go on ahead and open up label image. So I'm going to minimize this for now. And what I first want to do is inside of our data folder, I want to create another folder. So we're going to create another folder called labels. So we should now have two folders inside of our data folder: images, which contains all of our images, and then labels, which at the moment is blank. Then what we're effectively going to do is we're going to point label image to our images, and we're going to, so that we're actually going to be able to label those images, and then we're going to point the output to this labels file repository. But that's fine. We are going to do it in a sec. So what do we need to do? We need to start up label image now. So let's go on ahead and do that. So I'm going to open up a new command prompt, and I'm going to go into my D drive, cd YouTube. I'm just going to make sure my, where's my YOLO folder? It's YOLO v5, so 29. And I'm going to activate my environment because I'm currently using one. That's purely optional if you've done it. Cool. So I'm now operating inside of the same kernel. So I can actually just clear this. So I'm now operating inside of the same kernel where I've already installed my dependencies and where I've got everything set up. So what I need to do is actually go into, key point to note is that if you're not working with a virtual environment and you're just installing into your local PC, you don't need to do any of what I just did. So as in activating my environment, you can just use the base environment inside of your computer. But if you get stuck on this, hit me up in the comments below. I'm more than happy to help you out. So now what we're going to go on ahead and do is go into our label image folder, so cd label image. And then what we can do is actually start up label image. So I believe it's Python and then label image.py. And you can see this is label image now opened up. Now, the cool thing about label image is that it makes it relatively easy to go on about labeling your images for object detection. So what we first up need to do is open up our images directory. So we can over here just hit open dir. And I'm going to point that to where we've got our images that we collected. So right now it's inside of data and then images. And then this is, it's not going to show you any images in here, but this is where all of our images are. So if I select that folder, you can see all of our images are in there, and you can actually browse through these just using the WASD keys. And you can see we've got them all there, right? Cool. All well and good. Now, what we first up want to do, or what we secondly want to do, is change our save directory. So right now it would be in the same folder. So we're going to choose change save directory, and we are going, it's already pointed there. So we are going to go into our top level folder, go into data, and then go into labels. So we're going to save it all inside of this labels folder. And then what we can go on ahead and do is start labeling our images. So remember, we're going to have two different classes, so drowsy and awake. So this particular image, even though it's a little bit overexposed, is an image of me awake. Then the next ones, as we go through them, we're going to do drowsy. So let's go on ahead and do this. Now, in order to label an image, you need to just hit Q on your keyboard, and this is going to allow you to label. So all you then need to do is go to the uppermost. So we're going to label our head, right? So I'm going to do that, and I'm going to type in, this is me awake, hit OK. Oh, another key thing to note is that when you are actually labeling this, because we are using a YOLO model, what we need to do over down here is choose the YOLO format. So there's a bunch of different formats that you can save this as. So we want to save it as YOLO. So there's Create ML, Pascal VOC. We want it saved as YOLO, right? Really, really important. So this is going to change the regular output format that you'd get from label image to a format that YOLO can work with. So just make sure you've got it saved as YOLO, or make sure you've got it set as YOLO, and you should be good to go. And then what we're going to do is save this annotation. And let's just make sure that we're actually saving these. So if we go into data and labels, you can see that we've got our classes output and we've also got our different annotations. And what you actually get inside of this, so let me actually take a look. Does this have all of our classes? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wait, it'll start at 0. That's cool. So what we're going to get out of this is an annotation in this format. So this is the YOLO format, a little bit lightweight. So it's going to give you the class number, and then it's going to give you the, the YX coordinates. I can't remember the order, but it's basically giving you the different coordinates for your image. And these are normalized coordinates as well, key thing to remember. And then you're also going to get this document called classes. Really, really important that you keep that folder in there as well. So these are all the different classes that YOLO or label image by default is going to have associated. That's fine. Don't worry about the fact that we've got those other ones in there. It's still going to work perfectly as long as that you've got awake down the bottom and eventually drowsy. So what do? We hit W, we labeled this image. Now we can go to the next one, hit W again, label that one. And this is going to be awake as well. Save it. Just double check that we've got our second one saved. Cool, so we've got both of them in there now. All right, let's keep going through. So I'm just going to keep hitting W, labeling them. Ooh, this one's blurry. This will be interesting. All right, we're going to speed through this. So I'm going to power through this and label all of the images for awake, and then we'll be back in a sec once we're ready to go to drowsy. Okay, so we're now up to the drowsy images. So we're going to, again, as per usual, hit W on our keyboard to open up our crosshairs. And what we're going to do is, again, select our head, or my head. And this time I'm going to change the class. So we're going to change this to drowsy. So you can see that down there. So rather than labeling it as awake, we're going to label it as drowsy and hit OK. Save, and let's just go and double check our classes. So you can see that we've got all of these, and inside of our classes.txt document, you're now going to have the drowsy class as well. You can see we've got drowsy as well inside of our classes text files or inside of our annotations down here. So we are now good to go. Let's keep powering through. So we're going to keep labeling these ones drowsy now. So again, I'm going to hit W, make sure it's drowsy, save. Drowsy, save. All right, I'm just going to power through these and we'll be back once we're done. Okay, that is all of our images now labeled. So again, if we go through them, you can see that they've all got classes. So again, you can use A and D to go left and back and actually go through all of these images. So you can see that they're all labeled. These ones are all drowsy, as you can see up here. These ones are all awake, which you can see up there. Okay, that is, and so now that that's done, you can actually just close this down. So we don't need label image anymore. We are good. We can close down this command prompt. And we're good to go now. So if we go and take a look at our data, so we've got all of our images. Let me just hide this preview pane. So we've got all of our images there, and we've also got all of our labels there as well. So that is, or inside of our labels folder. So we've got all of these annotations now good to go. Now, all that's left to do really is run our training command. So let's actually go on ahead. I'm going to write this out and I'm going to walk you through it. So let's do it. Okay, so that is our training command now written. Now, there's one additional thing that we need to do before we actually go and run this, but let me actually walk you through this first up. So what I've written is exclamation mark CD YOLO v5. So remember we cloned our YOLO v5 repository right at the start. So right up here. So what we're first up doing is we're CDing into that. And then we're going to, so by passing through end, we're going to run the Python train command or the Python train.file. So let me show you this. So if we're going to YouTube and then YOLO v5, so what we're going to do is we're effectively going, let me zoom in, YOLO v5 and then train.python. So we're going to be using that over there. Then what I've gone and written is --image 320. So this is going to be the size of the image that we actually go and train on. I've passed through the batch size. So we're going to pass through a batch size of 16. So again, you might need to adjust this depending on the size or performance of your GPU. And then I've gone and passed through the number of epochs that we want to train, which in this case is going to be 5 different epochs. And then this is where we've got to do a little bit of additional work. So I've gone and passed through dataset.yaml. So --data is then I've passed through dataset.yaml. So this effectively gives us our configuration for our training run. So as of right now, we don't actually have this set up, or I've got it set up from a previous run, but we're going to do it from scratch. And then the last thing that we need to do is pass through the weight. So what model that we actually want to train on. And in this case, we're going to pass through YOLO v5s.pt. And this is actually going to download from the main repository. So you don't actually need to have these PyTorch weights actually pre-downloaded. It's going to do it for you. But let's actually go on ahead and create this dataset.yaml. So I'm going to delete the one that I've already got in there. So you can see I've got one here. And what we're going to go on ahead and do is create a new dataset.yaml file. So let's do this. So I'm going to open up a code editor. So I'm just going to use VS Code for this. And I'm going to create a new folder and we're going to save it as dataset.yaml inside of that YOLO v5 repository. So make sure that when you go and save this, it's inside that YOLO v5 repository. So we're going to call it dataset.yaml. And it should be a YAML file. Save that. All right, so at the moment, we don't actually have anything in this. So let's actually take a look at what we need to include in this file. So this is actually from the official Ultralytics repository. So if you actually go into, so let me show you where this is. So again, YOLO v5. So if you go right down to the bottom where it says training, if you go to tutorial, oh, this is actually going to give you information about training, but we actually want to go to the train custom data bit. And we need to create this over here. So you can see that it says create dataset.yaml. So what we're going to do is copy this, paste that in there. And we basically just need to specify these different components. So let's go on ahead and fill this out. So there's a couple of things that we need to fill. So namely, we need to specify the path, or this is our root path. Then we need to specify our training path, our val path, and our test path. So I'll explain this in a second. So our path is our root directory path where our data resides. So in our particular case, it's going to be -- or // And then we need to specify where our images are. Now, our images are just inside of a folder called images. So we can actually just specify it like this. We can get rid of these comments as well. So we don't need this. We don't need this. And we don't need this. And we can get rid of this. Cool. So our top level folder is going to be ..data. So this is going to go outside of our main folder into our data folder. And then our images or our training images are inside of a folder called images. And we're just going to use the same images for our validation as well. So again, this is not optimal. You'd probably capture some more images if you wanted to. In this case, it should be fine. And then we've gone and specified our val, or where our validation images are. In this particular case, we've gone and specified that it's the same folder as our train folder. And then we can get rid of this test component. We don't need that. And then in terms of our number of classes, so NC represents the number of classes that we want to capture. We basically just need to represent all of the different classes that we've got within. Let me find where we are. So if we go into YouTube, all of the different classes that we've actually got within that classes file, within our labels. So if I go into data and then labels, we just need all of the number of classes that we've got in here. So if I copy that, so you can see we have 1 to 17. So we've got 17 different classes. So I'm going to copy this. I'm going to type in 17 here. And what we actually need to do is we need to actually paste in all of our different classes that we've got here. So we can actually delete all of this and paste in our class names. And we're going to convert this into a series of strings. That's probably a faster way to do this, but I am not the greatest at VS Code. So what we're going to do is convert all of these to strings and add a comma between them. Cool. So now we've got our class names now made available. Now I'm just going to bring it all into one line. Okay, so that is our dataset.yaml file now set up. So basically all we've gone and done is we've gone and specified our root directory for our data. So ../data. And this is going to be where it looks for your labels as well. So your labels folder needs to be inside of that top data directory as well. So again, remember we've got it set up correctly. So if we go in, we've got data. So this is going to be our root folder. We've got our images here and our labels here. So we are good to go. Then we've gone and specified where our training images are, where our val images are. So we just need to specify images. Let's actually make this a bit bigger so we can see. And then we've gone and passed through NC, which represents the number of our classes or how many classes we've got. And then we've gone and specified all the different labels that we've got inside of the same order that we got from that classes.txt file that's generated by label image. And I've just gone and put it all on one line as well. And so we've wrapped those inside of quotes, so they're all strings, and we've added a comma between each one of those. So if we actually save that now and close that down, let's actually take a look at that dataset.yaml. So again, this needs to be inside of the YOLO v5 folder. So you can see it over here. So dataset, and then to YAML file. So if we open that up, again, this is all the stuff that we just went and did. So that's pretty much it when it comes to setting up your configuration for training. Now, if we go back into our notebook, let me open this up. We can effectively now go and run this line, and this should kick off our training. So let's run this and see what happens. Looks like we've got an error there, and it's saying it hasn't found our YAML file. It should be in there. What have we done? Dataset.yaml properties. Oh, so right now it's a .yml file. That's sounding promising. I can hear my GPU spinning up. Nope, we got an error again. What's happened now? Okay, so it looks like we've got another error there. And you can see here that it's saying broken pipe error, error no 32 broken pipe. So in the GitHub repo, you can actually see that there is some resolution for this. And the way to solve it is to drop the number of workers that PyTorch is using at that particular point in time. So we can actually solve this by adding -- workers and then setting that equal to either 1 or 0, 1 or 2. So ideally, this drops the number of compute capacity that you're utilizing for this run of training. So what we're going to try is, let's try 2 to begin with, and sometimes you might need to restart your kernel with this. In this case, let's try 2 and see how we go. And we'll also increase our number of epochs. So I was sort of just testing out 5 to begin with, but what we ideally want to do is test out for, let's say, we'll do 500, maybe we'll stop early and test it out from there. But ideally, you want to train for more than 5 epochs because it's going to take a little bit longer to get a reasonable model. So if we go and kick this off, you can actually monitor your training inside of the YOLO v5 package. So if we go into the same folder that we're currently operating out of, so YOLO v5, and then inside of our runs folder and inside of train, you're going to have all of these experiments. So we've currently kicked off our run, which is the latest run. So it's going to be EXP15. And you can see here that we're already starting to get some results for our model. So you can see that we've got our initial batch test results. We've also got batch 1 and batch 2. So the fact that it's starting to generate these files indicates that our model is training successfully. But the most important thing is if you actually go into your weights folder, you're going to have these batch or best.pytorch weights available. So this means that our model is now training successfully and will effectively be able to leverage this. You also get a whole bunch of additional information about your labels. So you can see that all of our images are in the awake and drowsy category. We'll also have a labels parallelogram. I always have a tough time pronouncing that, but you've also got this. So there's a whole bunch of data that's already generating. Now we're going to let our model train. So we'll probably give it around about 10 minutes and then we'll be back and we'll be able to test it out. Alrighty, so that is our model finished training. So I gave it around about 7-ish minutes to train. So you can see, so we've finished training, so you can't see because I haven't shown it to you yet. But you can see in here that we've got our best.pt file and our last.pt file. So if you go into your root folder and go into YOLO v5 and then runs and then train, and remember our last experiment was EXP15. So you can see that we've got a whole bunch of information here. We've got our results folder. And what epoch did we get up to? So we got up to about epoch 411 down there. Looks like our model was performing pretty well. So again, so you've got a whole bunch of metrics about, I believe this column is accuracy. Don't quote me on that, but I believe that's the column we need to be looking at. So again, you can see it's performing reasonably well, but the proof is in the pudding. So we actually want to go on ahead and test this out. If you want more information as to what's actually contained inside of this results file, do hit me up in the comments below. I'll see if I can get some information on that for you. But for now, let's actually go on ahead and test out our model. So we stopped it at about, what was it? So we stopped it at about epoch 411. Now, what we actually want to go on ahead and do is load this model. Now, I actually had to stop this notebook when we were sort of debugging. So what we need to do is make sure that we bring in our dependencies again. So I'm just going to bring in this torch section, and we are going to bring in this section over here, which includes UUID, OS, and time. So let's bring those in. And then what we're now going to do is load up our custom model. So remember, inside of that folder, inside of weights, we've got best.pt and last.pt. So we're going to try using the last.pytorch weights to be able to load up our model. So let's go on ahead and load this up and we'll test it out. Okay, so that is our model now loaded. So in order to do that, I've written model equals torch.hub.load. And then to that, we've passed through a couple of parameters. Now, I had to pass through force reload to make sure that we download the latest version of our model. So we're going to test this out and see if it actually works. So torch.hub.load, and then we've passed through ultralytics /YOLO v5. So exactly the same as what we were doing up here. And then rather than passing through YOLO v5s, which was the small version, we're now passing through custom because we want to load our custom file. And then all we need to do is point to that custom file. So YOLO v5 /runs /train /exp15. So that was experiment 15. Then we're going to point to our weights and then /last.pt. So this is going to load our last set of weights. And then I've passed force_reload equals true. So I actually got an error when I tried to reload it, wasn't able to find our last cache files. So that is the way to go around that. Now, what we can actually do is test out this model. So what we'll do is we'll actually pass through one of our images and see if it works. So let's give this a crack. Okay, so that's the path to one of our images. So I've just written image equals os.path.join, and then I've passed through the path to that image. So data, images, and then the name of the image. So I've just gone and grabbed the file path to one of our images, and let's test this out. So we can then pass that image to our model. So results equals model, and then pass through our image. And then if we take a look at results and type in .print, so you can see it's detected something. So one and drowsy. So let's actually go on ahead and render this. So remember, we can render using plot.imshow. And if we type in mp.squeeze and then pass through our, what are we passing through? Results.render. And we need to pass through matplotlib inline and plot.imshow. Oh. And then plot.show. And there you go. So it's actually detected drowsy. So you can see that there. So it's loaded up our image. It's detected that particular class and it's detected drowsy. Let's actually try a different image. So if I go and grab one for awake, let's pass that through. And you can see it's gone and detected awake. So initial results are looking promising and we've got a good confidence interval there. Now, what we can actually go on ahead and do is copy the same code that we used in step 4 for real-time detections and use this to perform real-time detection of, I keep zooming out, real-time detection of whether or not we're drowsy or not. So if we paste that there, this should theoretically work. So let's try that. And ideally we should get a little pop-up. Okay, so it's saying I'm drowsy. Let's drop the green screen and see how we're looking. So this is telling me I'm awake, drowsy, awake, drowsy, awake, drowsy, awake, drowsy. So look at that. That's actually performing really, really good. So you can see it's detecting our face. So when we're wide awake, drowsy. So as we start to lean over, it's starting to transition. So if I close my eyes, so that's awake. Start to veer off, I'm drowsy. Awake, drowsy. Awake, drowsy. So you can start to see, I mean, we haven't done too much data pre-processing, but it's actually able to detect whether or not we're awake or drowsy. So initial phases are working pretty well. And we trained for what, 411 epochs? So you can see I'm awake, drowsy. Awake, drowsy. And that's it, guys. So you can start to see that these are initial results. So you can see as I move my head, maybe it's not so great, but at least it shows that I'm looking away from the screen, eyes wide open, and that's giving me awake. Pretty cool, right? Drowsy, awake, drowsy, awake, drowsy, awake, drowsy, awake, drowsy. Okay, that's probably enough testing. So you can see that that is now our real-time drowsiness detection model actually working. So again, this model seems to work reasonably well. What do we train on? Like 20 different images per class, and we only train for 411 epochs. So again, you could obviously train it for a whole heap longer, add more images, add different angles. So you can see as I turn my head, it's transitioning to drowsy. So head straight on is awake. And then because we obviously, when we were collecting our images, we were starting to say that head tilted might be an indication of being drowsy, but this is good, right? So like if you were driving a car, ideally you want your head to be straight and you looking, but we might actually benefit from adding images with our head turned to a particular angle, because that might still mean you're awake. You might just be checking over your shoulder as you're merging. But again, you can start to see the initial phases. So awake, drowsy, awake, drowsy, awake, drowsy. And reasonably good confidence intervals as well. 0.8, 0.9. Pretty cool, right? So that about wraps it up. So we've gone through quite a fair bit. So let's all go all the way back. So again, this has been quite the journey. So we first up started by installing and importing our dependencies. We then went and loaded our initial model from Torch Hub. We then went and made a bunch of detections with our images, performed some real-time detections with the baseline model, which used Coco. We then went and collected our images, labeled them, and trained on that. And remember, you've got a few different things that you might need to go through when you're actually going on ahead and training. But remember, if you get stuck with that broken pipe error, that just pass through -- workers equals 2, or just -- workers 2. So that's passing through that particular argument. If you get stuck on an error around about, so that particular model doesn't exist, when you go to reload the custom model, just pass force_reload equals true, and that should help you work through that. But in a nutshell, that gives you the ability to go on ahead and perform your initial phase of drowsiness detection. Thanks again for tuning in. That about wraps it up. Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give me a thumbs up, hit subscribe, and tick that bell so you get notified of when I release future videos. And let me know what you thought about this implementation. Now, there's definitely ways that we can potentially improve on our drowsiness detection model, maybe extracting our eyes and our mouth to see whether or not we're yawning or whether or not we have our eyes closed. But this is just a beginner implementation, ideally to be able to leverage the YOLO algorithm, and specifically the Ultralytics YOLO V5 package. Thanks again for tuning in. Peace.